Hello, people. Welcome back to another session on complete .NET Web API tutorials. So today we'll start off with where we had left from the last tutorials. So we had created stored procedures. So if I just go to DB and the DB project, we have just created the stored procedures. Now let's publish it and actually test if the stored procedures are working as expected. So I'll just right click and publish. I'll just select the publish profile and click on publish. And once it gets published, we'll just check if the stored procedures are created in SQL, and we'll try running the get SPA record stored procedure. Okay, it's published. So let's move to SQL. I will just refresh stored procedures. So we have all the stored procedures created here. So let me just query the tables, companies and employees. If you see, there are three records in each. So let me just execute this stored procedure, the SP get records. So I'll just click on execute and I'll pass the table name, which is the parameter. I'll just pass TPL companies. And the columns I'll keep null for now. So if you see, we are getting the result as expected. So let me just remove this. Yeah, so we are getting the result as expected. So let me now, since we had not supplied the columns attribute, it was giving me all the columns. So if we need to specify some columns, we can do that, wherein we just specify the name. So say if we want the name column, address, and country. And now if we execute the stored procedure, it gives me exactly that. Now let's change this to table employees. And let's change this to say age, position, salary, and execute that. Bingo. So here you see, so with just one stored procedure, you can implement and get the records from all the tables. So this is how flexible the dynamic stored procedures will be. And if I just remove the columns attribute, it should give me all the columns from employees table. So being said that, so now let's move back to our application and start building our generic repository along with UnitOfWork. So in the previous tutorial, I had shown you the class diagram. So we'll be building this class structure now. So let me start off with creating the generic repository. So let me go to applications project, common interfaces and persistent. So I'll first create the iGeneric repository interface. So let me right click, add new item. I'll just say interface. I'll call it as iGeneric repository. So once I do that, I'll just remove this public interface. So I'll make it a generic interface of type T, and we add a generic constraint where T is IDB entity. So this is the interface which we have created where every entity inherits from this. Now let me start by declaring some methods in this interface. So these will be the generic ones where any entity uh, can use these generic methods to for the basic CRUD operations to perform. Okay, so since we have the generic repository ready now, let's go ahead and create the concrete class which will inherit from generic repositories. So we do that in the infrastructure project. So all the interfaces and the abstractions will be residing in the application project, whereas the concretions will be in the infrastructure project. So let me go ahead and add a folder called repositories. Okay, let me also add another folder called data context. So basically we'll be using Dapper. So let me name it as data context. And let me go ahead and create the Dapper context class first. So I'll just add a class. I'll name it as Dapper data context and name it as Dapper data context. So now if I just remove this, I'll name it as public sealed Dapper context, and let me start the implementation of it. I'll just paste it here. And so if you see, we are injecting the I configuration instance. So that will be used for pulling up the connection string from the app settings file. So if you see, we'll pull up this connection. So we need to install some NuGet packages here. So first one will be Microsoft extension configuration.abstraction so that we can use the I configuration. So let me click here and download the latest one. So once that's added, we can verify if it's added. Just use the namespace, and if you just go to infrastructure dependencies and see it's already added. There is one more dependency which we need to install. So if I just check this, so that is Microsoft.data.sql client. So let's install this as well. Click on that and download the latest one, which is available. Once that's installed, let's quickly verify if it is installed. And yes, it is installed. Now what I'll do is I'll just into the namespace. Yeah, so this is basically the Dapper context class, which creates the connections and manages the references for the transaction as well as connection. Okay. The next thing what we'll create is the concrete repository, which will inherit from the iGeneric repository. So let me just add this class. I'll name it as generic repository. And this one will also be a generic repository with the generic constraint of IDB entity. So let me just change this to public. And let's inherit from my generic repository of type P as well. And also add the generic constraint 40. After doing that, the next thing what we'll do is we'll inject the Dapper context class here, and we'll add the constructor for this. And then we'll implement all the methods which are defined in the interface. Just paste it here. So now if you see, we are still missing a NuGet package here, which is Dapper. Let's go ahead and install Dapper as well. Let's go to NuGet package and click on Dapper and download the latest version of Dapper. Once Dapper is installed, let's just quickly verify whether it's installed. Yeah, so once that's installed, let's include the namespace of Dapper. And now if you see, we have a basic repository already set up with all the basic CRUD operations, which can be performed on any entity which you'll be adding. Okay, so if you just have a look at this, so it is calling the stored procedure sp get records. This is for get async method. It is calling the sp get records stored procedure, passing in the parameters. And this is the way you can pass parameters using Dapper. So this way is actually safe and it prevents from SQL injection. So if you see, we have implemented all the methods similarly. So it is using connection and query async of type T. We are passing in the parameters which are required by the stored procedure, and the command type is stored procedure. So if you just have a look at the next method, yeah, so one more thing I need to show you is in the previous tutorial, we had created the extension method, which were actually getting the table names and the property names using the attributes which we had created. So this is where it is exactly where it is used. So this is the parameter which the stored procedure will accept, that is the table name. And this will be the value of the table name. So the way it will pick it up is using the extension method. So whatever type we'll be supplying here, may it be company, employee, it will go to that type, call this extension method here, and fetch the respective table name, which is mentioned here, and then call the stored procedure. Similarly, it will fetch the property names in the subsequent methods. Like if you see this one, get table column names, and it will accordingly get the data to form the query, which is placed in the dynamic stored procedure. Okay, so in this way, we have implemented all the methods. If you see add async, here it takes column names as well as column values. Again, it is calling this method, which is get column values for insert. So if I can show you that method here, it is this one, get column values for insert. So it is using the get value method from reflection to achieve that. And finally, it is, since this is an insert, it is calling the insert store procedure, and it is calling execute scalar. Similarly, it is done for update. If you see this, and this time it's getting the values by calling column values for update. If I go to the extension method and show you this method, get column values for update. So this is how it is implementing it. Again, it is using the get values, get value method, which is used in reflection. Okay. Finally, we come to the soft delete method implementation. So soft delete, we had created two store procedures, one for the main entity soft deletion, and one in case if there is a foreign key. So if you see here, so there is a parameter which is passed in this method, which is by default false. It says soft delete from related child tables. So in our case, if I want to delete a company, and since a company has a foreign key relationship with the employee, so company can have many employees. So in that case, if this is true, it will first execute the store procedure, which will soft delete the record from the company table, and then it will try to get all the foreign keys, which are, or all the associated child tables, which the company's table or the parent table for that matter has, and then call the SP soft delete foreign key record store procedure so that it can soft delete the parent in the records from the parent as well as the child table. And if this is not set, or it is set to false, then it will just soft delete the main entity. Okay, so now since we have set up the repository, the next thing which we need to do is, if we just see the class diagram, we need to set up the specific repositories. These were the generic repositories where all entities can use it. But if in case, apart from the basic CRUD operation, you need to do some other complex logic, then you can definitely have individual specific repositories where that implementation can be done. Let's create that. And then we'll also create the unit of work. Okay, so let me go ahead and create the new repository. I will just create a new repository for company. So I company repository. Create and go ahead and create that. So it will inherit from iGeneric repository, and the type will be company. So any specific company related implementation or methods you have will go here. And similarly, we will create one for employees. So let me create interface employee repository. And also do the implementation for that. So I just delete this. And this will again inherit from iGeneric repository, but this time it will be of type iEmployee. So since we have now created the specific interfaces or abstractions for this, let's go ahead and create the concretions for those specific classes. So if I go to infrastructure and inside repositories, I will add a new class and call it company repository. I'll create a company repository. And since I don't want this class to be inherited, I'll just make it as sealed. And this will also inherit from iCompany repository as well as generic repository. So we'll inherit from generic repository. So if you see the class structure, this will inherit from generic repository as well as the interface iCompany repository. So it's will be a company. And it will also inherit from our company repository. Once that's done, let's just generate the constructor. So since the generic repository is expecting a Dapper context, we need to supply this. Now, similarly, what we'll do is we'll create the employee repository and class employee repository. And similarly, it will be inheriting from generic repository of employee and iEmployee repository. So once that's done, let's go ahead and create the unit of work. So let me create the interface for unit of work, which is unit of work. And so let me just remove this. It as public. And now let's also inherit from iDisposable. Since we'll be managing a lot of connections in our unit of work, we'll inherit from iDisposable so that the dispose method can be used for basic housekeeping and dispose all the connections properly. So if you see, we have references of the I company repository and I employee repository, that is companies and employees here, as we have seen in the class diagram. So all these arrows you see are the references to specific repositories. So if you add more entities in future, we'll have to have the specific repositories uh, which are added, and then have references for them inside our unit of work. In the upcoming tutorial, we'll also see how we can optimize this using reflection, and instead of again and again creating these, we'll have a way where we can automatically create the instances of these. So now, since we have created the iUnitOfWork interface, let's go ahead and create the concretion for that. So inside for systems, I'll just add class for unit of work. Unit of work. With add make it public, and I'll also inherit from iUnit of work. Once that's done, let's just go ahead and implement all the methods. And so let's first have the Dapper context, which is created. So we create the Dapper context, and we will have constructor where we can inject this. We'll just inject this piece here. And I'll just paste this part. So this is the implementation for the unit of work. So if I just assign this here. Yeah, so one more thing I need to do is I need to call this init method. So if you see, this init method will actually do the initialization for the company repository and employee repository. And we are missing the two properties which need to be inherited from our unit of work. Let's just include them. Yeah. So if you see, we are manually creating the instances and passing the Dapper context, passing the Dapper context instance. So this can be optimized further. So we'll do that in the upcoming tutorial. But for now, we'll just do it manually. Now, let me walk you through each of the methods. So if you see begin transaction, it will just open the connection and begin the transaction. Similarly, commit will do the commit and then dispose it. Commit and close connection will commit it and dispose as well as close the connection for you. And finally, we have a rollback implementation, which will roll back and then dispose. So if you see the dispose method, it will do the house cleaning, housekeeping, and dispose all the connection instances, if any. So since we have the entire setup ready now, the only thing we are missing is injecting these dependencies. So if you see, unit of work is expecting the Dapper context. So let's go to organization.infrastructure. And if you remember, in the previous tutorials, we've created the configuration and specific dependency injection classes for each project. So let's go to that and let's inject the dependency for the infrastructure class. So that will be Dapper context. So we can just add services.add scope. So we have injected that. And there's one more dependency injection we need to do, that is of unit of work. Yeah. So let's do that now. So now finally, since we have set the generic repository, let's try to build a project. So if I just clean the API and build it, let's see if we get any errors. And I think we should get an error because in the first tutorial, we had just hard coded the company model. So we might need to change that. Yes. So if you just check, let's go to company controller. So if you go to company controller, we have a hard code in the companies because we didn't have the implementation for database and repository. So now since we have that, let's change this implementation. So let us remove this hard-coded implementation, and instead what we'll do is we will inject the unit of work here inside the controller. This implementation also will change in the upcoming tutorials because this is not a good practice to inject the unit of work instance inside the controller, since the presentation logic should be free from all data or infrastructure related items. So we'll be taking it up in the upcoming tutorials, wherein we define another pattern, which is called CQRS, which is command query responsibility segregation. So, so for now, just to see if our API is working properly, let's inject the unit of work inside the controller here. Let me just inject it here and then start implementing it. So once this is done, let me also do the dependency injection for unit of work here. So if we go to configuration and dependency injection of this, and we just add the dependency injection for unit of work inside the configuration of dependency injection configuration of the presentation or API project. Okay. So now since we've done that, let's go ahead and start implementing this. So what we do is, let's go to get companies. So for get companies, what we will do is we'll remove this, and the way you can call it now is we'll use underscore unit of work dot. If you see, we have companies now, companies dot, and we have get async. So get async will give us the required result, and we can just await this. Okay, similarly for get companies by ID, get company by ID. So let me just change this to 22 because it will take in an ID of the company. And now what it will first do is we just paste this here. Will do is it will first get the ID, check if it is not found, it will say not found. Then let's go ahead and add the company and then update and then delete. So let me change this to 22. Okay, so one more thing which we can do is, instead of returning the entity models, it's a good practice to create data transfer object or DTOs. So let me go ahead and create a folder called DTOs here. So you can always create request and response DTOs. So whatever request is there, you create DTOs for that. For that, I will just create a DTO called company request DTO. So let me just add a class called company request. That's done. Let's use that. So we created the DTO. Now let's go ahead and complete the add company method from the controller. If you just see here, we will add the company. So the way we can use this here is it's taken company request, the video which we have just created. Let's call this as company request. Yeah, so the way we can use this now is we use unit of work begin transaction, then we do unit of work.companies.add async and add the create the company instance here. Okay, so what else does the company need? So if we just check, so the company will need the name, address, and the country. So these will be taken care of by default because paging order is an identity column, so it should take care of itself. So we've done this now. Now let's move ahead with update company. Now update company will also take in company request and the ID by the first company request. We change this as well to company request. Let's change the implementation. So now if you see, it will first find the ID, required company. Then if the ID is not equal, it will send a bad request. If it's not found, it will send not found, and then this is where the new entry will be updated. So company name, address, begin transaction, and then commit transaction. And finally, we come to delete company where we do the soft delete which we have. So here we'll also include another parameter from the body where we call it as delete associations. And we just complete the implementation for the company here. If you see now, we have, so first it will try to get the ID of the company, whichever is supplied. Then if the company is not existing, it will say not found. And then it begins the transaction and calls the soft delete async and passes the delete association. So if it is true, then if there are any uh, employees associated with that company, those will be deleted. If not, if it is null, then it will just delete the main entity. So now since we have completed this implementation, so let's clean and build the project once again. Let me build this project. And now let's run it. Let's check the tables first. So if you see here, we have 3 companies and 3 employees. And there it is, we have our Swagger page. And if we run this now, I'll just run this. And that's it. So we have successfully implemented the API. So we have pulled up the records from the company's table. using the dynamic stored procedures, using Dapper, and also using a generic repository pattern along with unit of work. Let's also try something else. So let me take the ID of this company, IT Solutions Limited, and try to see if the other endpoint is working fine. So let's paste it here and try to get the ID. So yes, so we got the record perfectly. That's ID IT Solutions. So now we try to add another company, which let's try to post this. So I'll just name it as Microsoft. Let me name this as Microsoft. We just put some address and let's say this is UK. And let's click on this and you see we've got a success response. So we have successfully created a Microsoft company. And let's again run this to check if it's getting populated here. If we see the response now, we have another company which is coming up, which is Microsoft. And if we check the database, we have another entry which is for Microsoft. Now let me also run the update and change these values, update these values. So if I go here to the put endpoint, specify the same ID, specify the ID of Microsoft, paste it here, and call it as Microsoft one. Address will keep it the same. Well, let's update this also. I'll just add 1, 2, 3, 4. And this one will change to United Kingdom. Okay, so let's have a look at this. So currently it's UK, Microsoft, and this. So let's update. And if you see, we get a 204 response, which means it's updated, but we don't have any content. So now if we try to get the company and check the record, you see it's 1, 2, 3, 4 United Kingdom, and if we just check the database, it should be the same. So we successfully updated it. So now let's try the soft delete, how it's working. So let's apply a company ID which has employee ID as well. So if you see, we have Kane Miller, who belongs to Admin Solutions Limited. So let's delete Admin Solutions Limited. So we'll put in the ID of Admin Solutions Limited, and we'll also specify true for deleting the child entities. Let's click on execute. And if you see, it has successfully executed it. Now, if we try to get all the companies, we should not get IT admin solution. We should not get the admin solution limited because that's already deleted. So now if we just check the database here, so we have successfully implemented the soft deletion. So if you see this company ID as well as the employee ID, Kane Miller, is also deleted. So that's it for this tutorial. So we have successfully created an API which uses Dapper, dynamic stored procedures, and generic repositories using UnitOfWork, and successfully able to perform basic CRUD operations. So in the next tutorial, we'll cover up basically items like pagination, sorting, filtering, because that's a basic requirement which most of the applications have. If you want to just pull in the data and display it in a tabular column or a tabular format in the form of a table, you just need to bind the data and do pagination. So that's what we will be covering up in the next tutorial, which is server-side pagination. And that's it from this tutorial.